So every routing protocol picks a best path by comparing some metric. The path with low metric is always preferred path. As OSPF compares the cost, as EIGRP compares the composite value, bandwidth and delay, RIP compares the hop count. Every protocol has got some metric to compare the generated metric, calculated metric of between multiple paths to a destination and picks one best path. But BGP don't do that. BGP won't do that. BGP will not focus on any metric. You cannot change OSPF cost. See, you may change the number, cost number from 50 to 500. That's not the one I'm trying to talk. In OSPF, you cannot say we will not consider cost anymore. We will consider something else. Can you do that? Not possible. Because they are metrics. That is the base. அந்த பேஸையே நீங்கள் எடுத்துட்டீங்கன்னா அந்த ப்ரோட்டோகாலினுடைய ஐடென்டிட்டியே காணாமல் போயிடும். எப்படி புரோக்கா போடாத முஸ்லீம்ஸ் எல்லாம் அப்படின்னா முஸ்லீம்ஸினுடைய ஐடென்டிட்டியே காணாமல் போயிடும். அதை சாவடிக்கிறது தான் இவங்களுடைய பிளான், திட்டமே அரசியல்வாதிகளுக்கு. ஏதோ கலவரம் ஏற்படுத்தணும், புரோக்கா போடக்கூடாது அப்படின்னு ஒரு கலவரம் பண்ணுறது, அப்புறம் மற்றவங்களுடைய தலைவர்களை பற்றி பேசுறது, இதெல்லாம் எதுக்கு வேணும்னு அவங்களுடைய அடிப்படையை அப்படி டச் பண்ணிட்டோம்னா எல்லாரும் கொந்தளிச்சு எழுவாங்கன்னு தெரியும், முன்னாலேயே தெரியும், திட்டமிட்டு அஜெண்டா இதெல்லாம். ஸோ அந்த ஓஎஸ்பிஎஃப்லேருந்து நீங்கள் அந்த காஸ்ட்டை எடுத்துட்டீங்கன்னா ஓஎஸ்பிஎஃபே கிடையாது. ஆனால் அப்படி கிடையாது பிஜிபி. பிஜிபியில் நிறைய மெட்ரிக் இருக்கு, ஆனால் அதை மெட்ரிக்னு சொல்ல மாட்டோம். ஏன்னா ஒன்று இல்லைன்னா இன்னொன்று, இன்னொன்று இல்லைனா இன்னொன்று, அது பேர் மெட்ரிக் கிடையாது, அது பேர் அட்ரிபியூட். BGP has got a lot of attributes. OSPF அப்படி கிடையாது. காஸ்ட் அவுட்டா வேற எதுவுமே கிடையாது பார்க்கறது. But BGP has got rich metric, meaning many metrics in sequence. If there is tie in one, it will choose the other one. If there is tie in the other one, again it will choose the next one and compare. So it has got attributes to compare. Attributes, it has got attributes to compare. BGP has got a rich attribute. Based on that attribute only, path is going to be selected. So if you can go and handle these attributes, if we can go and manipulate these attributes, we can achieve a path which our policy demands. We can choose a path as per our policy demand, just by going and tuning those attributes. Right, so depending on what you expect, you go and tune one of the attribute. There are many attributes. If you understand how these attributes behave, you will know which attribute to tune to meet your requirement. You have many attributes. So let's talk about the different categories of attributes. See, this is not metric, no? So you will definitely have some categories. You should have some categories. All cannot be in same category. Then it will be like one metric only. What is characteristics means, Actually, I mean characteristics. Maybe you can also put it in different categories. Characteristic means what? குணங்கள் எல்லாம் ஒரே குணமாக இருந்துச்சுன்னா அப்போ அது ஒரு மெட்ரிக் தான், அது பேர் ஆட்ரிபியூட்னே சொல்ல முடியாது. ஒன்றும் ஒரு குணமாக இருந்தால் தான் அது ஆட்ரிபியூட்னு சொல்லுவோம். குணங்கள். ஸோ எந்த குணத்தை நம்ம டியூன் பண்ணால் நமக்கு தேவையானதை அடைய முடியுமோ அந்த அந்த குணங்களை போய் நம்ம டியூன் பண்ணணும். கேரக்டரிஸ்டிக்ஸ். Characteristics of path attribute. Some are well-known attributes, some are optional only. And in that well-known, some are mandatory to be seen in every BGP update. It is mandatory to be seen. It should be there. If it is BGP update, it should be there. Those attributes are called as well-known, mandatory. Well-known discretionary is an attribute which may be present, not must be present, may be present. That is well-known discretionary. See, I am covering this one. Well-known means popular, known by every BGP appliance. Such attributes that are known by, those attributes that are known by every BGP appliance means ZTE router knows it, Huawei router knows it, Cisco router knows it. All BGP supporting devices know about this particular attribute. Such attributes are well known. In that we have mandatory, discretionary. Mandatory means it should be there on every BGP update. Mandatory. Discretionary, though it is well known, it is discretionary, meaning it may be present. Sometimes it may not be there. It may not be there in the update. Such attributes that may be present, may not be present, they are called as well-known discretionary. Those attributes that are mandatory to be seen in every BGP update, they are well-known mandatory. Next, optional. Optional can be seen by some BGP appliance. Means you cannot expect this optional attribute from every vendor. Maybe Cisco will have it, Juniper may not have it. Huawei may have it, ZTE may not have it. Those attributes are called as optional attributes. Let's say you have an optional attribute, and if you find that optional attribute in the advertisement from your neighbor, you are very happy. See, you have an optional attribute. That same optional attribute is also coming as an advertisement from your neighbor. You are very happy because your neighbor also knows what you know. The optional attribute. Neighbor also uses that same attribute. And you process it and you use it, you advertise it. We call it as optional transitive. See, when you see that optional attribute coming in the BGP update, you gladly, happily take it and use it and advertise it. Such attributes are called as optional transitive. You are doing the transitive here. You are advertising it. You are using it and advertising it. Next is optional non-transitive. Okay, before that, let me finish optional transitive one more time. Optional transitive is, if you see with the update, you gladly use it and you advertise it. Sometimes when you don't see, then also you accept it, but you mark it as partial. See, when it is seen, it is full, not partial, it is full. You're very happy. But when that optional attribute is not seen in the updates, you are not happy, but still you accept it partially. You agree to use it partial. Partially it is good. So when there are two advertisement, one is partial and one is full will be preferred. But you don't discard it, you still use it by marking it partial. Those are called as optional transitive. Optional transitive, even when the optional attribute is not present, you still accept it as a partial update. You don't discard it, you accept it. Next is optional non-transitive. What is optional non-transitive? When that optional attribute is not seen, it discards. When a router receives an update, it will look for that optional attribute. If it is not seen, it will discard, which means it is optional non-transitive attribute. Only if it is present, I will be happy. If it is not present, nakoddu. I don't want. Beda. Right, that is optional non-transitive. Ask me a question if you have. Very clear. In optional only we have a partial. When do we have partial? When an optional attribute is not seen, you still accept it as a transitive one by marking it as partial. You don't discard it, you accept it. Let us read these lines. You can read it by your own because you have understood this. Read it now. Any question in this page? Read this. Any question in this page? All right. So some of the attributes are listed here. These are the important attributes. The other attributes are dynamically used, but these are the attributes that we have control. We can tune it to meet our policy. Now, policy in path selection. Now, AS path, next hop, origin, local preference, multi-exit discriminator. These are important to know in depth. The first three, well-known, mandatory. Local preference is well-known but not mandatory. The first three, AS path, next hop, origin. They are well-known. What does it mean? Can someone explain? They are well-known and mandatory. What does it mean? The AS path, next hop and origin are well-known and mandatory. What does that mean? Correct. Let us go and see whether it is seen in the. So we are capturing packet between R2 and R3. Because R2 and R3 are already configured with BGP. See, 179 three-way handshake has gone, which means the BGP has already come. Here it is. You see, BGP is already up. We see keep alives, but I want to see an update packet. So what I'll do is I'll just make a change in one of the router. So that update will be sent. On R3, okay, there is an update message already here. Let me check this. See, update message should have those attributes I was talking about, but there is no network advertised in the update. So let's advertise the network. As of now, there is a network, but it is okay. Let me capture this. No. Or I can do one thing instead of, see, we have already advertised, but I couldn't capture the packet. What I can do is I can clear so that it will send an update again. Clear IP BGP star soft. You see, it sends the update message, a refresh message. See, wonderful. It is sending about a network. See, NLRI means network layer reachability information. This is the network it is advertising. You remember? That is the network command you used, 10.23/16. So it advertises, when it advertises, it will always advertise with attribute. You see, origin is well-known mandatory. Correct? Origin is well-known mandatory. Next stop, AS path. All these are well-known mandatory. See, AS path, it is empty because it is from the same autonomous system. Next stop, router 3's address. All right, so these are well-known. It should be seen. See, multi-exit discriminator, MED. See the local preference. These are all well-known attributes. But in this 5 well-known attributes, only 3 are mandatory. AS, origin, next stop. Those 3 are mandatory. Local preference may be present, may not be present. MED may be present, may not be present. See, local preference will not be seen if it is eBGP. MAD will not be in use unless you have dual homing, right? So I have showed you the packet capture. Let's go back, right? So let's learn one by one. What is AS path attribute? It shows the autonomous system path number via which the advertisement has come to this route. For example, router B will learn about 192.168.1.0, which is from A, via C. A is the originator. C is the middle transit autonomous system. So when B receives it from C and C receives it from A, they all belong to different autonomous systems. When C receives it, it learns the path like this. It learns that B learns that I am learning from 500, which is this 500, and 500 is learning from 520, which is this 520, from where this is originating. So if you have list of AS number, the last number is the originator, the first number is the immediate autonomous system. AS path is always advertised. When I showed you the capture, we did not see AS path because we were not seeing that from the other autonomous system. We were seeing from the same autonomous system. Yeah, exactly. If you have 1 million AS autonomous in the middle, you will see all 1 million in one big queue. Let me show you that. Here it shows only 2 hops because it is only 2 hop in the. It's a lab environment, no? In the real world, it will be like one big sequence of number. Yeah, it shows the path via which you learned. It shows the AS path. So your question is, if I trace route, will I be able to know in which AS the problem is? Of course, yes. Because sorry. Because you know that EBGP addresses, you know the EBGP addresses. So if it gets stopped in one EBGP address and the trace route gets struck there, now you need to go and see which autonomous system number has got that EBGP address, neighbor address. Then go and troubleshoot there. Problem is there. Correct. What you say is correct. All right. Now next attribute is next hop. This is not new to you. This is well known mandatory attribute. You see, router C will learn about this network with the next hop of this. Router C will learn 172.16.0.0 not with the address of B but with the address of A. Why? The EBGP address will be carried into IBGP. See? By keeping 10.10.10.3, router B is advertising it to C about this 172.16 network. Next is origin. See, origin is nothing but a small attribute which will tell you how this network got added into BGP. You can add a network into BGP by advertising using network command. Is there any other way that you can add network into BGP? One is network command. We using network command we advertise. Do you know any other way through which we can advertise network into any protocol? Redistribution, no? Redistribution is one another way. So if you redistribute, you will have question mark, which is called incomplete. If you use network command, you will have I. I means internal to the gateway protocol, IGP. Here this IGP is not talking about IGP routing protocols. Here it means interior to BGP, internal to BGP. It's internal to BGP. IGP means internal to BGP. See, older version of BGP is called as EGP. Older version of BGP was EGP. So if you see an update, you will know whether someone has used a network command on the BGP router, or someone has used network command on EGP router, or someone has redistributed from OSPF or from some other source into BGP. That is what called as origin attribute. Origin attribute informs all the autonomous system in the internet work how the prefix were introduced into BGP. Did you understand that paragraph, 3-line paragraph? The origin attribute informs all the autonomous system. See, it is not only within the autonomous system. For us to understand, let me explain you. From France, Joseph is advertising a network using network command in BGP. In Australia, down you have something called Perth, a place called Perth. In Perth router, I am sitting and receiving what Joseph has advertised. Sitting there in Perth, I can very clearly tell Joseph has used a network command. He has not redistributed. How? Because whatever the number of autonomous systems may be in the middle, that doesn't matter. This attribute is always attached and advertised to all autonomous systems just to inform how the prefix, how this network got introduced into BGP. Any question? No. I told you EGP is an old protocol of BGP. No one is using it nowadays. So no need to worry about it. It is good. It's no more. In case if someone is giving from EGP and the other one is giving from IGP, it will prefer IGP, not EGP. I is preferred over E is preferred over question mark. EGP is preferred over incomplete. Alright, that's the preference level. I is preferred over E. E is preferred over question mark. Smaller is preferred. I is smaller than E. E is smaller than question mark. Yes, of course. When you redistribute any route, it can be from static route, it can be from OSPF, any other source into BGP, it will be considered as incomplete. All right, fine then. So we will continue this attribute, next